Hello everybody, it's Sunday again, and that means it's time to get back to basics. Today we are going to talk about the ohm. We've touched on it briefly in previous videos, but I just wanted to go into some more specifics about the ohm. Now, we can define the ohm as an electrical resistance between 2 points, where if you apply a constant voltage of 1 volt and a constant current of 1 amp, you'll have 1 ohm here. Now, we'll talk about the mathematics for calculating the ohm. And there's a bunch of different ways to do it. They get wackier and wackier. There is a cat hair adhered to my whiteboard. So, the ohm is equal to volts over amps. We've talked about that one before. It's equal to 1 over the number of Siemens measured. I don't know if we'll ever talk about Siemens. It's a fairly obscure electrical measurement standard. We can also say it's equal to watts over amps squared, and that's just a reshuffling of our power formula. We can also say it's equal to volts squared over watts, yet another reshuffling of our power formula. Pardon me. We can say it's seconds measured over farads. And they get steadily weirder from here. But mainly the only ones you're ever going to worry about are this one, this one, this one, and maybe that one. If you need any stranger ways of measuring the ohm, it's available on online. But we won't cover those here. So, we can also talk about power as a function of resistance. So, before we've calculated that P equals IV. Now, we can substitute values in where we can also say that P is equal to V squared over R. In case you don't happen to have your current measurement available, but you do have volts and resistance, you can calculate power. And you can also calculate power without volts handy by saying that power is equal to I squared R. And I talked in the last video about the watt, about I squared R losses in electrical circuits or in electronic circuits and electrical wiring, wherein you're losing efficiency due to heat, and we colloquially refer to those as I squared R losses. Now, the standard for measuring the ohm used to be, and I need to double check on these units, I want to make sure I have them right. Get yourself some mercury, weigh out 14.4521 grams of mercury. Then you need to construct a column of continuous cross-section. This would not be a good example of that because that is not continuous cross-section. And that column needs to be 106.3 centimeters long. And then you need to pour your mercury in there and cool it to 0 degrees Celsius. And then you measure from here to here. And what you're going to get, although it used to be 1 ohm, but now it's been more accurately defined with something called the quantum Hall effect, which I won't go into here because the quantum Hall effect would probably be a series of videos of its own, and I'm here to teach you electronics, not quantum physics. Anyway, so that was equal to 0.9537 ohms. Now, for the basic multimeter, for the hobbyist, having an accuracy of 5/100ths or 5/1000ths of a ohm is not, no, that's 5/100ths, tens, hundreds, thousands. So that's pretty good for most multimeters, but when things started needing to be super precise, they needed to redefine the ohm. Anyway, so there's not really much more to say about the ohm, so I'll go ahead and wrap that up here. If you have any questions or comments on anything I left out or corrections, please leave it in the comments below. Consider clicking here to subscribe to my channel, and also click the bell icon over there if you'd like notifications when I release a new video. Over here, I'll put a video that YouTube thinks you'll like based on your watching habits. Over here will be the Back to Basics playlist. And here, if you choose to be generous, is my Patreon link. So if you have a couple extra bucks you'd like to send my way, go ahead and click there and check out the Patreon page. Thanks so much for watching, and we'll see you next week.